So in this video, we are going to examine the math that's involved in determining how many courses of ice and water are required at the eaves of a residential roof replacement, especially when the regional building code requires it so. Now, if you don't already know, ice and water barrier is an adhering underlayment that is applied directly to the plywood decking or the OSB decking. It is commonly installed to prevent ice damming from getting inside the home, and a lot of regional building codes around the Denver metro area and above 7,000 feet in the El Paso County area require it on their re-roof guidelines. But sometimes mistakes are made when you're trying to factor in how many courses of ice and water are required from your eaves. If you don't know the math, you might make a mistake. So this video will show you how to do the math and properly calculate how many courses of ice and water you will need at the eaves, as well as some other important information. So let's take a quick look at the vocabulary involved with determining everything that we are talking about. So as we're figuring out how many courses of ice and water the eaves need, let's go over the vocabulary real quick. When we are factoring ice and water, you need to know the materials on top of the roof. That's what we call the roof. The board underneath the eave is considered the eaves or the soffit board. Then you have the exterior wall, which is the wall of the home that is exposed to the elements. Then you have the interior wall, which is also known as the warm wall. And this is called the warm wall because either the sheetrock or the plaster, whatever the home has, that is on the interior of the home that is exposed to its heating system, that's why they call it the warm wall. The difference between the warm wall and the exterior wall most typically is a difference of 6 inches, and this is important because this is going to come back when you start to do the math to determine how many courses are needed at all eaves. So in this first scenario, let's go ahead and say that the soffits are 12 inches and the pitch of the roof is 612. That's pretty standard. For this scenario and the next one, let's say regional code requires that 24 inches of ice and water has to go past the warm wall. Now, when code talks about 24 inches past the warm wall, initially they are talking about the footprint. The footprint being it is parallel to the ground. So from the warm wall, it has to go 24 inches. So the steps for that is first you have to measure the soffit and the eave, which is also part of the photo checklist that you have in your field guide. So you go ahead and measure it, take a photo of it for the insurance company, and in this instance, yes indeed, the soffit is actually 12 inches. So we have 24 inches from the warm wall. Now we've measured 12 inches from the exterior wall, and then of course you have to add the 6 inches of the wall between the exterior wall and the warm wall. So when you add that up, we have 12 inches of soffit, we have 6 inches of the actual wall, and we have the 24 inches required from the inside of the warm wall. That means this is the point on the roof where code requires us to have ice and water installed to meet the code. The next step is you have to take your 42 inches total and multiply that by the pitch conversion. So in this first scenario, let's say the pitch is 612. The conversion for 612 is 1.12, and that conversion table is actually also in the back of your field guide. So if you take your 42 inches required and you multiply it by 1.12, you come up with 47.02 inches to meet the code. So that means when you've pitched the roof, this is where your 47.02 inches of required ice and water applies. Now every roll of ice and water is considered one course. One roll of ice and water is 36 inches wide. And keep in mind that there should be a 5 to 6 inch overlap between courses. So we have a need for 47.02 inches. We divide that by 36 inches, and that gives us a need for 1.31 courses to meet the code. Obviously, we're going to round up, and that means 2 courses are required at all eaves to meet the regional code. Okay, so in this next scenario, number 2, we're going to examine a roof that has no soffit and has a very steep pitch. So again, let's say the code requirement is 24 inches past the warm wall. So again, we have a footprint of 24 inches, which requires our ice and water to reach this point on the roof. Again, our wall is 6 inches, and since there is no soffit, our soffit is measuring at 0. For this scenario, let's say the roof is pitched at 12-12. Going back to the conversion, a 12-12 pitch converts to 1.415. So when you look at the math again, we have 30 inches to account for times 1.415, which equals 42.45 inches. 42.45 inches divided by 36 inches per course equals 1.18 courses. Again, we are going to round up, and even though there is 0 soffit, we are still going to require 2 courses to meet the regional code based on this pitch. Just as a reminder, there is a page that talks about ice and water factoring in your sales and business development field guide. But here's a basic guideline that I call the 6607 guide. If the home has 6 inches of soffit, it's going to require 2 courses. If the house has a 612 pitch, it's going to require 2 courses. If there's 0 inches of soffit, that means anything greater than a 712 pitch is also going to require 2 courses. If the soffits are less than 6 inches, it may only need 1 course if the pitch is 712 or less. But as always, still do the math to make sure you got it right. So the last thing I'm going to go over in this video is when you have a dormer or any part of the roof that is a patio covering, like over a front door or possibly a back door patio. Now, if a dimension report is involved in the job, clearly you'll have the square feet that you need to add into your calculations as to how much square feet is going to be required to do the job to code. But for the sake of learning, let's just say you don't have that dimension report. This video will show you how to measure things from the ground and do the math to figure out how many square feet are needed to cover that dormer and get it past the warm wall. First off, you get your measuring tape out, and from the ground, you measure from the exterior wall all the way to the edge of the rake. For this scenario, let's say that measures at 120 inches. So again, we need to add 6 inches for the wall itself and another 24 inches past the warm wall like the code dictates. You add those up, and that gives us a total of 150 inches. Next, you're going to have to measure the width. So once again, grab your tape and measure from one edge of the eave to the other edge of the eave. Again, for this example, let's say that measurement is 144 inches. Now from the ground, you're going to have to use your pitch conversion to figure out how many actual inches there are on that dormer. So in this case, let's say the roof is pitched at 712, and the 712 conversion, which is in your field guide, comes to 1.16. So you take your 144 inches, you multiply that by 1.16, and that gives us a total rake measurement of 167.04 inches. Now that you have your measurement, let's go over the math for determining the square feet. The depth under the dormer is 150 inches. You divide that by 12 inches, that gives you 12.5 feet. The width measures 167.04, and divided by 12 inches comes up with 13.92 feet. Then all you have to do is multiply 12.5 by 13.92, and that will give you 174 square feet. Now you know the amount of square feet that you need to cover that dormer and bring it up to code. And again, don't forget to refer to your ice and water page in your field guide. So hopefully this video helped you with the math to figure out the number of courses of ice and water at the eaves of a residential property that's required by their regional code.